Hey everyone, welcome back to another episode of Tweak, Test, and Repeat. I'm Mr. Umer, and here's some more PC quick tips for you. In this video episode, I'm going to go over how do you optimize your Chrome for hardware acceleration or to get more performance. Basically, if I'm loading up a web page here, how do I get the videos or websites to be more snappier, right? So good thing is Chrome browser is pretty much a optimized browser for Windows, even for Android or other platforms, right? And there's going to be some good default settings out of the box. But obviously, if you're a power user, you're going to want to try to extract the most performance you can, especially if you have things like multi-threaded or multi-core CPUs from Intel or AMD, or maybe you have a very fast graphics processing unit, a GPU from NVIDIA, um, or from Intel or from AMD, and you want to be able to extract that. A lot of apps and websites are web based, so it's nice to have something that can accelerate quicker. Obviously, Google is a very simple page, right? But if I'm going to try to load something like Gamer Nexus, right? I mean, it's pretty snappy. All the images and videos. If I launch YouTube, obviously that takes longer there, but it was pretty snappy there, right? I have some acceleration enabled in there. WCCF Tech, I launched that. It might have some different things. Obviously, I have another thing I won't go into in this video is using good ad blockers to try to add some privacy and block a lot of those ads that could slow down the loading of websites, right? So I'm going to go back to Google here. One of the options that Google has is what's called the Chrome flags and the Chrome settings. So I'm going to type in here. I opened up a new tab. If you don't know how to do that, you can click it here and click this plus button. It'll open up a new tab. I still have my other session open. So I'm going to go ahead and type in Chrome colon, and it's already trying to autocomplete there, flags. So there's some advanced features here. We call them experimental features. Now you want to be very careful here. You probably want to do your research and make sure whatever you're changing in the flags is not going to brick your browser. I did enable one. I believe I tried to tweak some of the color format in the HDR settings, and it pretty much bricked the Chrome browser. I wasn't able to get it back easily, even with a reset of the browser. But eventually I got it back. But here, if you tweak the right ones, it's going to give you different performance benefits. Obviously, the first one is a lot of Apple, Microsoft, you know, Google products are going to use what's called dark mode, right? Because obviously it's not going to matter much here for my PC because I'm using a traditional panel, right? That it's plugged into the wall. But if you have a phone that uses an OLED screen, right? Um, light emitting diode, organic type, right? Um, that's gonna that's gonna have something where if you're running uh, an application or whatever that has color or a white background, that actually sucks a lot of battery. So you notice that the regular Google, if I go back here, um, it's black, right? But because I have dark mode enabled, right? If I type in dark mode here, and I went ahead and I reset it back, right? Default, right? Because right now Google usually doesn't have dark mode on, not for Windows at least. If I reset it, I click Google, everything's white. So on a Windows machine doesn't really matter, right? But it does. I notice I'm starting to squint now, right? It's really bright on me because this monitor has like HDR 1000, so it's going to go up to 1000 nits of brightness, right? And if you're young and you don't have contacts or glasses, maybe that doesn't really matter. But if you're teleworking from home and you're staring at the screen using Google a lot and working with applications, or you're in the Office cloud, that white background can be very debilitating to your eyes, right? Obviously you want to take breaks and not stare at the screen much, but workaholics like myself are going to be staring a lot, right? So that's not very pleasing, right? And Google is going to obviously for Windows type or desktop type platforms going to enable a dark mode switch somewhere. There might be added natively to the settings, right, to make it easier, or maybe to have a dark mode button or toggle switch. Now, when you're on a phone, that's actually going to save more power because on an OLED screen, you know, like on an Android here, having a white background there is going to suck a lot of power because on an OLED screen, when those pixels are turned on, it's actually using power. When it's actually dark, it's actually at almost zero power or a lower power state. So having a dark screen here, like on my phone here, I have a dark mode screen here. I mean, obviously a lot of people want to customize it and they have pictures of their family on there, but having color and white background is actually going to suck more battery out. Um, Obviously if you're mobile and you're out and about, you want to have as much juice as possible, right? Uh, Even if you have the battery optimization on, having dark mode actually saves power. It's been found, and maybe we'll do another video later and do a test and see how much battery life you can extend on there by having that. But on here, you do have the option to enable dark mode. I'm going to go ahead and go back to the Chrome flags. Type it in there. I'm going to type in dark mode there. Hit enabled, relaunch. Boom, if I hit Google here, actually let's go back. I want that settings open. Google is going to be in dark mode, right? Very, very nice. Now, that's going to optimize more for, visibility and obviously on a desktop you want to reduce eye strain and, if your monitor doesn't have a blue light filter, then a lot of whites are going to really, tear into your eyes, right? Another feature here, we talked about CPU and GPU acceleration is, if I type in GPU here, graphics processing unit, and you want to be able to utilize your GPU and your CPU more, I'm going to open up the task properties here, and you'll see, Windows 10 and even Mac, they have the ability to monitor how much your CPU and your GPU is being used, right? And you can tweak these settings, and you'll see when you play a video, it will either tap your CPU or GPU more. Now, if you have a very weak graphics card, and you're not running something from NVIDIA or AMD, maybe it's an Intel or integrated video card, basically a video card that's not discrete. It's not an add-on board, right? It might be something that's built into your CPU. It has a GPU component to it, integrated, which is cheaper and uses less power, right? It may be tapping your CPU more. Maybe you have a 4 or 8 core CPU, and if you run Chrome by default, it's going to tap into those cores, right? But obviously, if you have a discrete card or a good integrated graphics, even NVIDIA and AMD have that, you're going to want to, balance that load, obviously, if you free up your CPU, you can use it for applications that use the CPU a lot more, right? Like single-threaded applications, right? That, if you open up the CPU, there's some threads that you see. You run an application, it runs a task, it turns it into threads. So the more threads that the CPU has to process, the longer it's going to take, right? Obviously, if you're on a phone and you're running one application, it may not have many threads. Maybe it's more single-threaded, right? But on an Intel, AMD, x86, Windows type platform, there's going to be a lot of multi-threading, right? That's why desktops tend to be faster to run applications, lots of applications at once over time. Maybe you're rendering or streaming or running a game or running multiple applications in Windows at once. Obviously, you can see more, you can do more on a desktop platform, right? So depending on your hardware, your CPU and GPU should be balanced out. Now, I tend to gravitate more to GPU because GPU has you can parallelize a lot more applications in there. There's going to be some things like running graphics and video, um, video decoding, decompression, and decoding. That's going to run faster on a video card, especially if your video card has a lot more video RAM or VRAM, right? Clocked higher. Versus if you use your CPU, if you invested in a CPU like from AMD, you might have a 8, 10, 12, 16 core, or even an Intel which might have 8 or a more highly threaded CPU, maybe 32 core, right? If you invested in a CPU that has more threading, Obviously, you can run more, but a GPU, is going to have tons more cores. My GPU has 10,000 cores, right? More simpler cores, but a lot more cores that you can parallel a lot of tasks, right? And if you go back to some of my other videos, you can see that you can NVIDIA has its own and AMD has its own, but basically you can see some of the applications that are running here on the GPU. You can see it here in Windows Task Manager. Um, you know, Things that are being accelerated there. Um, Obviously, to set that, one of the biggest things is the Chrome browser or even Firefox and Edge have some of these similar settings. But I went ahead and I set everything to enable. It might be on default, which may or be on or off. But if you toggle it to enable, it's going to be pretty much on, right? And you probably want to, it'll ask you to restart or reload the browser and make sure things don't crash. One of the things that I noticed that crashes is your graphics backend, right? Basically, if your driver for your graphics card supports different things, different what we call API, right? API application interface, something that allows the operating system to access your hardware directly, right? We call that an API, right? An interface, or we call it a hardware API in particular, not a software API. Um, so on that hardware API, Windows is pretty big on using DirectX. That's their own baby, their bread and butter API. DirectX, obviously, there's different versions dating back to like DirectX 1, obviously, but the most common today are 9, 10, and 11, or 12. Actually, 12 is the ultimate that has all the different features like ray tracing, mesh shaders, different technologies that accelerate games and hardware, right, and applications. But for web browsing, it may be a little bit more rudimentary. Obviously, things like OpenGL, that's a more open source type graphics library. AMD, NVIDIA, Intel, they all do OpenGL, right? Even Mac at some point have supported it. I know they're going to be more platform dependent. I know Mac they use Metal, right? Which is obviously not as mature as OpenGL and Direct3D because a lot of these have a lot more developers and supporters that build applications that use these APIs, right? There's a lot more on the Windows ecosystem for that versus Mac, right? Versus Metal. But obviously, if you're running a Mac, you're going to want to select Metal if it's here. If you're running Windows, then OpenGL, for NVIDIA or AMD, they're more optimized, but they're always also optimized for DirectX also. I normally run DirectX 11 on 12. DirectX 11 is going to use more of your GPU, so you'll notice it here. 12 is going to use a combination of your CPU and your GPU, which could be a benefit when you're running, maybe you're running a threaded application back here and watching a YouTube video, or maybe you're doing some programming. Enabling that is going to give you a lot more performance. So, if I'm going ahead and I'm running an application here, let's say I went to, Gamer Nexus and I ran it, and it's pulling up a video. Obviously, you might get some sound reverberation there. Let me mute it so you can hear the sound.
We're back with the NZXE H1. So really fast turnaround time on what happened here. There's now a formal recall on the NZXE H1. We've been covering this case extensively for a couple weeks now.
So you notice there, I went ahead and I ran the video, and you notice that it spiked up on the GPU, right? If you had the settings set more to CPU or maybe a default, you might see more spikes in your CPU. Obviously, if you see spikes in your CPU, the temperature is going to be different, right? Your CPU and GPU have different cooling requirements. Obviously, if you're on a laptop and you run your CPU and it's an Intel, it might get a little toasty, right? You want to load balance that and run it on the GPU. Now, once it's gone to the GPU, you can see that decoding this video actually spiked up the NVIDIA, and it's using the hardware, and it might look a lot better on this video, and you might get better performance, and you can use that CPU for running something else that uses the CPU. So that runs pretty good here, and you can see that it's loaded on those GPU cores. Obviously, I'm running my camera and doing other things and other applications that are loaded on my GPU. So, running that setting is very, very, very useful. So I would enable that in your Chrome browser or any other browser that has the ability to change these settings. So that's all I have for these PC quick tips. Obviously, if you need more information, check the description and go ahead and like and subscribe. And that's all I have for today's video. See you next time. Bye.